about that partitioning, bucketing and all, right? I believe that you are good with that. Even we discussed about the alter commands where you can do all kind of changes whatever you are looking for, because most of the time in real time once our table is created, let's say one table is running since 2 years, everything is fine, but now a new proposal came for the same and two columns are needed to require, then you are not going to create the new table and load the data. You can alter the table, you can add new columns, and then new data will get populated accordingly. But some challenges will be there. Challenges will be in the sense, let's say you added new columns, then what will happen? If that table contains 2 years data, then for the last 2 years, that column will be having null data, right?
Yes.
Because data is going to populate from the day whenever you are doing the alteration and all. So prior to that, that column will be having null value. So this kind of challenges will be there. This is not a challenge. This is a kind of real time scenario where you have to think about either you are going to populate null value or maybe you are going to have some default value. In case of default value, you can run your SQL query one liner and you can populate default value for that column for the previous days, years, months, whatever. You can delete the column, you can rename the column, you can change the position of the column, you can add the partitions, you can drop the partitions. Only for the bucketing there is no alteration option. If you are looking for altering number of buckets and some other things to alter, then you have to recreate the table. For bucketing and partitioning, these are the main thing for the optimization, which are providing you a layer of optimization where we can avoid scanning the entire data, because as a data engineer, we are supposed to work with huge amount of data. We are not going to work with the MB and GB of data. Minimum it will be GB like 10 GB, 20 GB and something. Otherwise, this data will be, if you are getting good project with some, let's say finance, commerce and all, then you can deal with some 100 GB, terabytes of data. If not petabytes of data, then at least you will be having GB and TB, but with some kind of projects, you can have petabytes of data as well, petabytes and zettabytes. So that much data you have to deal with. And if you are planning to deal with that much data, then optimizations are the first key to take care. Otherwise, you also can write the program. I also can write the program. If I am writing the rough code and you are writing the a good code which is really performing very decently, then of course your code will be preferable, because my code is also good to get the output, your code is also good to get the output, but we have the time limitation. I have suppose 100 GB data and we have to process within 2 hours, then even my code is good to get the output, expected output I am getting, but if that is taking 4 hours and 6 hours, then what is the use? No use. Because I have to process within 2 hours. I have to take care of that much data. So optimizations are the first thing to be take care while doing the development. So partitioning is there where we can think about the partition to avoid scanning the entire data. So whatever you are looking for, you can use that. Then bucketing is there. Bucketing provides again uh, some other layer of optimization where you can create partitions separately, you can create bucketing separately, you can create partitions with bucket. If partition separately, then n number of folders will be created in backend. If bucket separately, then bucket means n number of bucket. Bucket is in your control. While creating the table, you can say number of bucket 3, 4, 5, 6, 10. Then that many parts of data will be divided internally and that will be placed to the folder your backend folder. And bucketing help to join and all as well, that is having some bucket map joins and all, that is providing good optimization. And you can have bucketing plus partitioning plus bucketing, that is again very beneficial, because let's say you're one of the partition, let's talk about 2024 data. Maybe my 2024 I am doing the partition by year, and my data got divided by year. But again, 1 year data also kind of 100 GB. Then I can have bucketing on top of that. Then my 100 GB data will be, if I am saying 5 buckets, then that will be divided into 5 parts, 20 GB internally by indexing is, let's say, hashing it takes internally, and I'm taking clustered by ID. Then based upon the ID column, that will get divided, and this will be more helpful again for scanning the data and all. So that things we can do. And then we have, once we are good with the partitioning, bucketing and all, then we have some other things. I talked about this setting properties, also table properties, where you can set up the description, you can set up some compression, you can set up I shared one real time example where your file is getting headers also with the file. Then you can take care, you can skip the header by line number 1. But sometimes not about the header, maybe you are getting some uh, unnecessary data in from maybe row number 1 to row number 100. You do not look for the data, you can skip the entire number of rows. So that also you can do in the table properties. In table properties, multiple things are there, you can do that setup. And these things can be done after creation of table. Let's say you created a table and your table is internal table. Later you are thinking that I want this table to change as external table. I do not want it as internal. That also you can do. You can change that property of table, that from internal make that external, and from external make that internal. We can do that. Then we discussed about this next part. Okay, these were joins. I believe that everyone is good with the join. Let's go with the exercises. If you are not aware about, if you are aware about joins and all, then that's a good. If not, then try to go at least one time. Just copy paste. If you are not willing to write the code and run this once, you will be good with it. Okay, here I have mentioned for bucket map joins and all. Bucket for bucket map join, your table should be bucketed. Then only you can do the join. And if you are doing like this, then of course it will be faster. If you want to experience it is faster or not, if you are comparing to the normal tables, normal joins, which table is not bucketed, you can take around 1 GB of data. Okay, and then you load that 1 GB of data into normal table also without bucket, and you load the data into bucket table also, and then apply the join, and then see how much difference is. Because if you have some 4 records, 5 records, whatever we are taking for the testing, there will be maybe micro milliseconds. We are not good to identify that much differences. Okay, but if you have good amount of data, then you will be good to identify. You can see if you are good to get the good amount of data from some sources. We have many online sources like Kaggle and all, right. And if you want to generate data on your own, that also you can. If you want, I can share the code where you can just write the code and you can give the desired value, and this will be creating the data of that much amount. Like, let me share you one. Let me share my screen. I was doing that actually. So I will like here I have created one transaction data creator and one customer data creator. So in this customer data, I want to dynamically I am creating the data. Okay. So I have some columns. I want few columns in my data like customer ID, first name, last name, DOB, address, phone number, email, join date, and is active. Is active customer or not? I was trying to create some financial data. I am using this faker instance, this faker. This will be generating some fake data. Okay, my file name will be, file path will be default. Here only my file will be created. If you want some specific path, you can give. You can give what is the file name. Here language wise, whatever name and name, address and all, I want Indian. So I am giving Indian. It is country specific. You can give language specific. Even I can give if I want completely in Hindi language, Hindi scripting. That means language you can choose country wise and language wise. Okay. And then so I want Indian English, but Indian names, name and address and all. Then I have given that, and here it is volume 10 MB in bytes, 100 MB in bytes. You have to just calculate that. While data size is, this will be keep on calculating 1024. Okay, and then how much I want. So if I am giving 10, this will be creating 10 MB. If I am giving 100, this will be creating 100 MB. If I am giving this 1 and 1024, then 1024 into 3, then it will be 1 GB in bytes. I can do 1 GB, 2 GB, 5 GB, how much volume you want to create. So this is for 10 GB only. If I run this code simply, and similarly, I have created for transaction date. So I can join both the data and all. Let me run this customer and you can see this. So this will be creating 10 MB of data. So this is very good. Based upon your requirement, you can have some column names and you can provide some specific thing like customer ID. I want 1, 2, 3, 4, 5, 6 like that. Then here I am giving customer ID 1, 2, 3, 4. It will be incrementing. So this created and this has generated this much count 82,316. This is a good number, right? So let me copy this and I will paste in my download folder. Here, let me open it. What happened? My Excel is not working or what? Let me open here itself. Something wrong. Mhm. Yeah, this is fine. Then why that is not opening? Comma separated. Okay, let me. I will check it later. Let me open with some other choose other app and let me open with Notepad. Here you can see, right? Customer ID, first name, last name, DOB, address, phone number, 1, 2, 3, 4, 5. This is the name. If you see, name also I had taken Indian. So it has taken this Indian name and all. So like that, this was ejective, true, false. So like that, you can create the data. So if you want, you can create the data with good amount, whatever amount you are looking for. And then you can apply in the joining and you can see how this is performing. If you have already good amount of data, then that's okay. No issue. If you need the code, you can let me know. Okay. Then for this bucket map join, you can exercise this, then semi join and NT join. These are just similar to your SQL only, and almost all kind of joins it supports from SQL. Some is additional in the sense this map join, bucket map join, and all. This is highly specific. Map join also I had shared yesterday. How what is this? This is for optimization where you have very small table, small data, and you want to join it with the bigger data set. In that case, it will be doing data shuffling in case of joining because both kind of data is sitting to different node. They need to join. For joining, they need to communicate with each other, and in that case, data shuffle will happen. If you think that one data set is very small, it can be fitable to memory, then why not to make that available to all other nodes so they can avoid shuffling data movement here and there. In that case, you can go for map side join and you can enable it and it can helpful. It can be very much helpful. Here you can see
Anamika,
yeah,
yeah, I have a question over here
yes,
regarding this map join.
huh,
So small table loads on memory, right?
correct.
So do we need to provide that? What is the Which table is the small table or it does automatically?
You have to set up. You have to give that.
We have to give the what is small and what is big. So small table.
Small table only it will be copy making the copy, right?
Okay.
Here I have mentioned all the steps. Like here, the smaller table should be able to fit in the available memory. It should not be, see, maximum value you can keep up to 2 GB and all. And you can plan if your data size is something like 500 MB, 1 GB, 1.5 GB and all, then it will be performing more better. Even you can set up the size. Then we can enable map site join in Hive with using the following step. First, setting the configuration. These are the configuration. Okay. Uh, and then you are here. Here also query with map join hint. If you are giving this map join hint, then it will be taking this reference, whatever you are looking for. Okay. Here you have employee table, here you have department table. So if we want to explicitly force a map side join with map side hint, in this map side D hint tells Hive to use the department table as map side table. It will be understanding, okay, this is the smaller data, and this is the bigger data. Then it will be making copy of this. Okay, because directly you are giving the hint. If you see here, if you are enabling, then it is taking based upon its own understanding. So in Hive map site join, whenever we are enabling all the properties which I had mentioned above, then we need to specify which table is a smaller table because it needs to fit in the memory for each of the nodes and the data for each of the mapper. So we typically provide the hint to load the data a smaller table into the memory, and when like you we are saying here a set Hive convert auto join true. Here we have option this one, auto join true, and then a small table placement. So for a small table placement, when you are giving this hint, this map side join hint, then you are giving this table reference D. Then it is taking that you are talking about the department table. Okay. And then even but in advance you have to check the table size. And if you want to set the property for adjusting the table size, let's say your table it is looking for maximum 2 GB and your table is something 2.1 GB or something. In that case, you can do the set of table. Here you have set high with small table. I have mentioned or not? I have not given that. Okay, so I will mention, I will note down here. Okay, you have to give set hive dot map join dot small table uh, dot file size. Actually, we have lots of configurations. Okay, and then here you can define the size in bytes, whatever size in bytes you have. You can provide that. Then it will be considering that much byte, that much size for the uh, small file to increase the threshold. If you want to increase the threshold, if you want to increase the size, that you can take. So explicitly we have to provide the hint which table is smaller, and then Hive will be performing the map side join. If you are not giving, then automatically it will be picking up according to the size. But it's good if you are doing that because this is a system, this is a machine. It may have something wrong. It can take the wrong references, and also better to go with your own whenever you are providing it. Okay. And then, okay, here I have mentioned the same set height map side join. Here you can set up whatever size you want to have as a threshold and map side join large table. Like this is the large table size, this is the small table size. These are optional. If you want, you can do. Then this one enable map side join. where set Hive properties, Hive to convert join, then it will understand that okay, you want to go with the map site join, then writing the queries. Whenever you are writing, then Hive will be using map site joins automatically when conditions are met. Conditions are met in the sense, first condition is your small table should be fitable into the memory. Let's say you have two table, you are not giving the hint. Means a direct hint you are not giving, you want Hive to take care of it automatically. Then Hive will be scanning which is the small, which is the big one. If any one is smaller, that is fitable to memory, and that is according to your threshold size, whatever you have set up, it will take that. Then force map join. If you want force map side join, that okay, this is the small table and you have to consider this only as a small table, then you can give map side join hint, and then uh, you just explain to check if map site join is used or not. This is for your validation. You using explain you can validate, and then tuning the memory and all. Tuning the memory means setting the threshold value for the tables data. So it will be working with that. Let's say in some scenario maybe that much memory is not available, or by default size is 2 GB only or 1 GB only. It will be almost 2 GB in most of the configuration settings, but your file size is something 2.5 GB. In that case, you can set up some threshold value. Okay. And this practice session I had mentioned, this is based upon a real-time interview from a very good product-based company. Okay. So that's why I thought to keep it here. You can have a look. This is based upon the window operations, window functions, where this is the input data with single row, single column with multiple row, and this is the marks. So based upon the marks, you have to get the output in this term, where you can see first 0, then 20, then 30, then 40. This is coming like one row down, and this is same. Then this is doing the sum 20 plus 30, 50, and then uh, 20 plus 30, 50, 50 plus 40, 90. Then again in 90 adding to 25. So this is the sum with the previous row. This is happening accordingly. So just to try to get it with window functions. And then this is the additional one. Additional one also you can take. And then views. Again, I will start with the view which was pending from yesterday. Before starting to this, I will ask the question if anyone is having something. No? All good? Okay. Okay. So in view, in real time, sometimes happens that you are having the data, good amount of data with good number of table, and same data needs to accessible by multiple team. In the internally I'm talking about, I'm not talking about external customers. If internally also many team want to access the data, but that is not right for everyone. It needs to have some restriction. In that case, you can create the view. And in the banking projects and all, this is more in practice. Okay, where we have the actual table. Actual table is having lots of column, and maybe some other team they are creating some dashboard on top of the data. They want to visualize some data, but not for all the columns, because some columns are kind of PII and non-PII. Maybe you have heard about that classification, data classification, right? So if that is PII data, then that is more restricted. We should not share. Non-PII, it is okay. In that case, if some data is too much restricted, then we can remove access from there. How you can table is same, table directory is same, then that would be more critical, because if you are removing a read access from the directory and or the table, then it will be removing read access for you also. But maybe if you have different, if you are maintaining by the groups and others and donors, then again you can maintain, but better to create a view for them. So out of 10 columns, you can create a view, select a star from ID, name, city, and skip another columns from the table name. then they will be having access for that three particular column only, whatever you mentioned. So you can create a view on top of the actual table and you can share. Then they will be having access of those columns only mentioned in the view. So this is real time use case. Okay. Interview wise also, sometimes you may get the question. Maybe you will be not be, you are not going to get the question directly that what is view, because they know that you can explain it. They can come via a real time scenario. Real time scenario in the sense, I will share my own experience. I was interviewed for a banking system. Question was, I am having a table with some 50 plus columns, and in that 50 plus columns, some data is restricted to access by others, and some data is good to go ahead, and need to share the same data table with some 4 5 parallel team for the different use cases, different analysis. How I will be maintaining the access? This is the question. Now this is up to you how you are going to maintain the access. Either you are thinking about the HDFS location purpose, HDFS location in the sense you are having a CH mode to provide the access for the HDFS, right? We have group owner and others where you can say CH mode 777. 777 means access to everyone, or you can have some other. Either you are looking out for that much access level or what. So this is up to you how you are going to reply. So exact reply will be view only, not the ch mode and all, because ch mode is having some additional thing, and again maybe that can restrict in some other way, you have to maintain one more layer, so better to go with views and all. Okay, so that is the question which is coming, but that is coming in round, that is not coming straightforward. So you have to take care. And again, view is not only for providing the access. This is for other use cases also. Let's say you are having some 4 5 tables, and you are building a dashboard, or maybe you are creating a report on daily basis. And for that report, you do the joining of the table, then you do some custom logic, you do some concatenation, you do some regular expression, you do some data cleanup and all, and you are going to apply this thing on daily basis, because daily every day you are generating the report, you are running the same query. Then why not to create a view, and then simply you can run the view. You will be refreshing the data. So view is something, just to create a query, save that query and go ahead with it. We have materialized view as well, that also you can create, and you have view as well. I believe that if you people are from database background, then you understand about materialized view and view. Is it? Or no?
No, Anamika, can you explain?
Okay, fine. Yeah. So we can create a view and MV. MV, if you are from database background, then you can get it better, because in this is a very common use case where we are creating the MVs and views. View is this one only where you do not have. Here you can see a view is a virtual table based upon the result set of an SQL query. We are going to just save the SQL query and created by combining multiple tables or filtering existing data. This is just a use case. As I said, let's say you have a daily reporting or something. You have developed a complex query. Then why not to save the complex query, and you can just query. You can run the table, right? You can run the view instead of writing every day. So that is just like that. This can be changed up to your requirement. Not physically stored. This is not going to store anything physical. Let's say you have an employee table and you are creating employee view, then data is actually stored into employee table only, but whatever query you have saved for the view, then it will be running that syntax, running that saved query on top of employee table only. And if table data is refreshed, your view will be also getting refreshed data. This generates the data on fly when accessed. So this will be data will be coming from the actual table only. This is not having any actual physical storage. This is the thing. And use wise, I said you already, mostly for simply simplify complex query. If you have complex query, then save the query, run that again and again. You can save your times and all. Reusability, you are going to reuse the query. uh, and then data security and abstraction. As I said, this is the main key role for the view, mostly in the project where data security is too much required. And if you are working with banking and all, then of course in banking kind of project, security is too much concerned and you have to take care of that. So in banking view is very much in practical. You will be getting this. So for data security and abstraction also, this will be in the picture. And then materialized view is also something same. Okay, but that is having materialized view stores both the query definition and the pre-computed result as well. View is not storing anything, that is not having any physical storage, but this will be having the pre-computed result, and this will improving the performance for a complex query and aggregation. And then data in materialized view is physically stored and needs to be refreshed to stay up to date if anything is getting changes in the base table. So view is not required to refresh the data or something, because this is completely depending upon your actual table. If actual table data get refreshed, then your view will be also having refreshed data. But as materialized view stores pre-computed result, so this needs to be refreshed along with your table. If your table is getting refreshed, then let's say you created a materialized view, then you should have a scheduler that is refreshing the data after each 30 minutes or each 1 hour, then that will be also getting refreshed. So, but this view is too much better because this is not storing any data and all. So view is not having any data storage. Materialized view is having performance-wise query executed dynamic, and materialized view stores a pre-computed result as well. That's why that needs a refreshment. And view is always up to date because this is directly going to main tables data, and the materialized view requires a refreshment. If you are having the materialized view, you should have a scheduler for that as well, and scheduler in the sense for the refreshing the materialized view. And a view mostly be used for simplifying the query logic, and materialized view we use for improving the query performance. Okay, and these things you will be getting in the real time if you are working with this. And one thing is view is available in Hive and Hadoop since the beginning, but materialized view is good. You, if you are from database background, you may have already experienced with this for creating this, and it uh, it was not available with Hive. It was introduced in Hive by Hive 3.0 version, means latest version you can see. Now if you are getting the opportunity to work with it, you will be having the support and you can create a materialized view in Hive. If you want to exercise and you are not having a latest version of the Hive, here Cloudera we have set up, that is the previous version, that is not the latest version. Okay, and if you are setting up Hadoop by downloading the Hadoop package from the Google, and you are setting up locally in your Windows, then you can set up with the latest package. Okay, like here for my Hadoop use case, my Spark use case, I have this training, and I have taken this. Uh, this is my Python 3.13 and WinUtil Master. Then I have Hadoop version. I have here 3.0 version as well. If I go to, so if you can see here, I have multiple versions of Hadoop. I can set up any. If I am going to 3.0, inside bin, I have all the things. If I am setting this up, then I can, it will be supporting me with Hadoop, HDFS and YAR. All the things are available and I can go with this. So with the latest version, if you are setting in your Windows, then we can set up with latest version and we can exercise that. Again, syntax wise, either you are working with Hadoop or you are working with database, same. If you want to just do the exercise and you are not setting up this Hadoop and done locally, then simply you can go with the database, and there you can create a view, you can create a materialized view, and you can see the syntaxes and all. In Hive also that will be 99.9% same. So you can do exercise anywhere, that will be better for your understanding. Okay. And then uh, here I have mentioned why you should create the view. So we should consider the view when we frequently use a specific complex query, which is involving joint segregation, filtering, and all, and we can create the different representation of the data for different users. Let's say you have a table, and for the same table, you are generating some four different kind of output, and all four different outputs are required by four different team. Then you can create four different view for everyone. Every day they can access their view. Okay, instead of creating that as a different tables. And okay, so let's say you have a table, and from that table you want four kind of output. Then what you can do, simply you can create four different table for all four users. Not required, because if you are creating four times table, then four times we are going to store the data physically, and this is going to take means additionally this is going to occupy some space. Not required, simply you can create a view for them and you can provide a view name to them, simply they can access that. Okay, here I have mentioned one other example, creating the view. We will create this view in our real time only, so let me create this view. We'll see that practically. So let me go to the Hive. And we have already a table. Let me check that. Huge learning. And let me do show tables. Yesterday we had created, it should be there. We have bucket table, partitioning with bucketing, employee test table, employee staging table. So let me go with this staging table only. Staging table is having all the columns straightforward without partitioning or bucketing. So let me do select a star from uh, employee staging. Employee staging. What is wrong? Hmm, what is wrong? Okay,
Left
spelling
spelling.
mistake. Yes. Okay, this is having this data, and then I have one temporary table also. Let me look into that. I have one test table. Let me do select test. Okay, here you can see some same name is getting Lake Rajesh one time. This is two times. So this is not unique, right? It is having some duplicate data because I have loaded multiple times. See, one time this I loaded this header also. This is wrong. It should not be. So I have to take care of that. Means you have to take care whenever you are loading that. So let me suppose I want to create a view, and that this is my actual table. Actual table is having some wrong data, which is having this null and all, right? So let me go with so create a view. If I do select a distinct name from employee staging. Employee staging. Okay, as soon as I give any logic, then this will be going to map reduce. If I am not giving any logic, then it is a simple query. It will be just push means we can get the data. Let it run. Then can create a view on top of this. So what I will do, let it run. We'll create here create view, and again I will repeat. Hive is not case sensitive. Even you can write in capital or in a small. That's good. Not an issue. Then create view name. Let's say that is my employee table. I can say employee view. Any name we can give as select. Then my this column name is id, then name, then whatever I am looking for. Let's say I am doing select star from as of now. Then I will add the logic. I will add some join logic later. And from employee staging. Employee staging. This is one. And if I am, let's say I am giving one of the example where I am having some product table, order table, some sales table, and I want to create a view on top of that. Then create a view. Or let's say I am having some sales related data, some product related data. Then here, if I go to this example, here I have mentioned for the same. I am having some order data. I am having some product data, and we want to get some revenue kind of detail. Then we can create a view based upon the logics of joins, groupings, aggregations, and all. Let me see. Okay. Here I can see the distinct name Amita, Amrita, Anita, Kavita, Priya, and okay, name is also coming here. That should not be. So what I can do, select a distinct name from employee where ID uh, is not equal to ID is not null. ID is not null. Select a distinct name. Yeah. Just give me 1 minute. Okay. So we were here, right? Select name, and I was looking for ID. Let me take this much only. Then we can create a view on top of that. So here, if you see, I want to take the distinct name, not other columns. You can refine it whenever you are practicing this. And even I want to not take this name also, because this name is not a valid value. This is just a wrong data, which is populated in the table by loading header also. So I want to filter that as well. Then I'm saying where ID is not null. Then it will be taken. Then let you can store this as view, and next time no need to write this much query. Just query the view and it will be working for you. So I will create two view from this. One is with this logic and another one is the straightforward by selecting few columns. Here you should understand about this map phase and reducer phase, that first map phase start. In that condition, map and reduce both will be 0. Then it will be first computing the map, which will be getting up to 100%. And then once 100% is done, then reducer will get started and reducer will be completing its output. Okay, now you see this has provided all the output, and it is not having this name right this time because this is coming from the ID equal to null. That is okay. Now I can create a view. Uh, create view, employee view, EMP view as select distinct name. Let me copy this distinct name where this is not null. ID is not null. ID is not null. Mm, yeah, it's okay. Not needed anything else because we do not have any complex query. This is simply if let me do show tables. If you see here, view is also there. Okay, what is this view? Does view is having any physical data storage? No. This will be working on top of this staging table only, whatever table I have given here. But I can query this directly, select star from view, and then I do not need to give whatever this complex query I have. This is a very simple query as of now. Only I am selecting the distinct and I am filtering based upon the ID is not null. In the real time, you can have lots of logics here, right? So all the logics you can mention, and then you can next time whenever my view is created, I am going to avoid all this complex logic. Simply I will give select a star from employee view, then I am good to query it. Okay, I am not going to provide all the columns, all the logics and all. So that's it. Then let's say I am having the employee table, and in this employee table I have some 4, 5, 6 in number of columns, and out of that I want to create, or I want to create the view based upon some joinings. I am having some 4, 5 tables. I want to do some joins and all, and then I can. So whatever logic you have, simply you have to mention here. Nothing else. Nothing else is required. Let it run. Then we'll move to next part. So these are some things which you have to take care very carefully. And whenever you are working with the project, if you are the junior resource, then of course you will be get guidance from your senior team member who is having good experience. But if you are the senior one, then you have to take care. No one is coming to guide you. You have to keep all the things in the mind that in which condition what I should do for better performance and all. And because you are the you are someone who is going to guide your team, so you have to keep all the things in your mind. Then you can have your better performance, because you have to see your performance as well along with the query performance, right? We have to take care of that as well. So let's focus on these parts. Here you can see I simply did that querying from that view, and then it took that. I am not going to query all the things and all. Now let me do describe this employee table. So I will do show tables. So tables, and I have some test table. Let me do describe employee test. Both are same table only. Just name I have given different. This is having ID, name, department, hire date. However, we want to create one view without any logic. Select. Let's say this is having 4 columns. I want only someone. I want to get access with ID and name only. Name from employee test. That's it. Then
Employee name is same.
thing is wrong.
View name is same.
Right. Employee test view. That's why I got the error analysis exception, that this is already exist exception. Again wrong. I have given this view double. Okay, I will drop this first, then I will create.
I this is not view name can be anything, right?
It can be anything. I am just removing this. Doesn't look so good. Sometimes what happens, let's say I am doing something, some exercise, and I did some wrong practice. Okay, not wrong code. Someone is keep on following me blindly. If I am doing wrong, they will also follow wrong. That's not a good practice. So I will correct myself. If I am correcting myself, everything will be good. Okay, so now this view gets created. If I do show view, so sorry, show tables. This is also considered as table only. Then test view. If I do now describe employee test view, then you can see only ID and name. Now, if you are going to share this view name with someone who need not have access for the department and had it, then your data is also safe, right? You can simply give this view name to them. Okay, this is the view name. You access this or whatever you want to do with this. So like this in real time, we take use of the view and materialized view. You can practice with the latest version and. I can say if you are not having set up with the latest version, you can practice the same with database. You go with the database, you create the view, you create the materialized view, syntax will be same. Okay. And anyways, in the Spark, we are going to practice with the database. So if you are not having setups and all, then that time, of course, we are going to do the setup and then you can go with the exercises. Next, we are coming here and this is just example I have mentioned. You can go and you can query all the things. Now we have indexing in Hive. In Hive, indexing is a mechanism that again for improvement of the performance, because as I said, performance is very much critical for the data engineering. We are going to deal with huge amount of data, and dealing with huge amount of data means very simple. How you are getting the output doesn't matter, because as a developer I can also write the code, you can also write the code, third person also write the code, and maybe all the codes are getting the same output, everything is fine, but only getting the output is not our achievement. Our achievement is it should be on time, it should be smooth processing, it should be quality, be with quality, and be on time means it should have quality also, so no error, it should be bug free, plus on time. If you are having terabytes of data, if processing time should be 2 hours, then 2 hours only. You can't take 3 hours, because if you were taking 3 hours, then maybe in that additional 1 hour, some more data came from the source. If you are not able to process the previous data only, how you will be taking up for the next coming data? Because next time we will be having 3 GB 4 GB data, 1 GB data, 1 TB of data and 2 TB of data will be from the lag from the previous hours. So better whatever we are getting immediately we should process, we should not keep the lags. So for that we have to be on time. So be with quality and be with time, both the things are very much required. So it's critical, we have to always think about the improvement. So this indexing is also a technique, a mechanism for the improvement, which is going to help for tuning the query, making performance in a more better way, and where this is going to improve the performance of queries by reducing the amount of data that needs to be scanned during every execution. And when we create an index on a column, Hive maintains additional data structure like a lookup table that allow it to quickly locate a specific row based on the column's value, that is similar to the traditional database. So as we are already repeating this same thing, if you are having experience with the database, almost 95%, I can say 5% I will exclude because that is highly specific, but 95% its architecture has been tried to maintain that if you are coming from the database background, you can do all the things in a good way, in the similar way how you have been doing in the database. So you can do perfectly. So this will be matching again in a database. If you have experience, maybe you have seen, you are going with the partitioning, you are going with the indexing, you are creating the lookup table, fact table and all, right? Anyone has created relation between the tables with the star schema and snowflake schema and all. Someone has did that. Anyways, here is no concept of star schema and snowflake schema. Just I am asking. if anyone has that much understanding. No? Okay, not an issue. We'll go through that one by one. Okay, so this is again helping us in query performance. And here, however, indexes in Hive are less commonly used than in traditional database, in our relational database, because Hive is designed for large scale batch processing and where full table scans are typical. Still, when query large data sets are filtering the specific columns, indexes can be beneficial by improving the performance. Means if you are working with the database, then indexing is very much common in use. In Hive, that is depends upon the requirement, depends upon the business, because we are going to deal with the good amount of data and in the batch with the file system. So if our requirement is to scan full table, then why we need additional things? I do not need any view. I do not need indexing. I do not need partitioning. If I need to have a, scanning the all table, then nothing is required. If I am having something that okay, I do not need this, I need this, I can add this. In that condition only we can go. So here indexing is optional. As per requirement, we are going to add. And in this way, this will be having bit differences with the database. Now, and again, you can see that this is less commonly used because sometimes what happens, indexes are there, bucketings are there, views are there, but most of the time people are not using because maybe that is not the requirement. That is one case. Second case, they do not know it perfectly. Means they can improve the performance by indexing if they know, but they are not fully aware about it. They do not know because everyone is not aware about each and everything, right? We can't say that I am expert 100%, but at least we can try to get the best whatever we can. So in that condition, if you know it, you can apply. So most of the time people will not be applying either. That is not the requirement, or maybe they are not following the best practice. We should always follow the best practice. If we are following the best practice, then we are going to get a good result. And if you are leading your team, if you are as a senior member, then always follow the best practice yourself and encourage your team also to follow the best practice. And I believe that if you are not today, you are at least leading 2 4 peoples. If not, then in future you are going to lead that. Then this will be working. Okay, in Hive, here I have mentioned types of indexes in Hive. We have Hive supports 2 types of indexes. One is compact index, one is bitmap index. So compact index, a basic type of index that stores the mapping of columns value to the block offset in HDFS where the data is getting stored. You know that how your data is getting stored in Hive. Hive means no storage. No storage for data, no storage for metadata. Metadata is getting stored with the database, maybe DB or maybe some MySQL DB, whatever is configured. Data is going to stored in the HDFS. Hive is just a place where you can query your file data in a tabular format. That's it. So this is a warehouse, not a table. Bitmap. So here in the compact index, this is a basic type of index that stores the mapping of columns value to the block offset in the HDFS, where the data is actually stored. So wherever data is stored, there itself it will be maintaining its mapping. Bitmap index, this is more efficient for column with low cardinality, means columns with a small number of distinct value such as gender or status and all. In that case, you can go for the bitmap and that performance will be even more better than compact indexing. You can use based upon the requirement when and use to use indexing in Hive. So there are some conditions where you can think about it. Queries often filter on the specific columns. If you are going to have some queries which is applying filtering and all on the specific columns, then you are having large data sets and you need to query the subset of data only. Their indexing can help you. Then selective query Whenever query return a small portion of data compared to the full table means you are going to avoid full table scan. In any case, whenever full table scan is required, you are not going with selective query. Then frequent joins on specific columns. In that case, also you can go for the indexing. Then why use indexing? Indexing is going to help you for improve query performance, reducing input and output operation. See, input and output operation is something that is always very much costly. And this was the main issue with MapReduce also. When Spark came in the picture, then it tries to avoid this input output. Again, we can't say that Spark is not having input output. Of course, that has. But compared to MapReduce, less because it has tried to make it possible that wherever possible it will be avoiding input output, that it is having capacity to process all the things with memory, so that can make your query performance faster. Okay, so this will be reducing input output operations and optimized for specific use cases. When just for example, if you know that your query frequently filter on certain columns, you can create indexes specifically for those columns wherever filtration and all you are going to apply, which will optimize the query performance. Here I have mentioned one other example. You can exercise the same. Okay, what I am doing, nothing here, just like view, we were giving the syntax, right? Create view, view name. Simply here you have to give create index, index name, and then on table, cells, any table. And this is the column name and edge compact or bitmap, whatever you have. Here we have, just a minute. Okay, then with the deferred rebuild, this is the simple syntax. You have to create, and then this is the first step, create the index. Second step, alter index. Okay, and on cells rebuild, and then run the query. If you want in future, you can drop the index. Okay, this is the simple step you have to apply. So here, create an index on the product ID column on the sales table, you can use the following query. Let's assume that you are having a sales table and you are having product ID. In our example here, I have created the table. I do not have sales table as of now, so we can create our ID column, employee ID column for the example. So create ID column, and this is the sales table. Okay, and table cells, this is the column name, and you can give any ID column name, and then with the same IDX product ID, here you have to create this rebuild, and then you can query that. Simply same we can follow here in our exercise. I will minimize it to take the query reference from here, and we'll do it. So let's say first I will do the describe table, a describe employee test. Our column names are ID, name, department, and headed. So let's say ID column for creating the index. So create index, and you can give any name. This is just a reference. Okay, employee ID, employee ID on table. Table is employee test, and then which is the column name? Column name is ID, and edge. Here I need to give either I'm going for the compact or bitmap, which kind of indexing you are looking for, with rebuild, deferred rebuild. So it is not case sensitive, but I am going to take it for readability. Deferred, DEFE, double RED, deferred rebuild. Deferred rebuild. So where is the option? Create CR, create spelling. This is wrong. Okay, so this index got created. I will do simply so tables. We'll check it. This index, right? See what it has taken. Learning. This is the database name. This is the table name, and then this is the index name. Even when I created, I gave only this index name. I did not give table name. I did not give database name simply, right? But it took table name from here and it took database name on which database. Currently, I am in learning database. So this referred that database name also. Now, I if even I can query right now also, but I will follow this step, rebuild the index. So this is alter index and my index name is idx and I had given employee id on table name. Table name is employee test and then rebuild. So we can alter and then we are good to query the data. And once this is done, then I can query. But you, as I said, if you want to really experience whatever for the optimization, how much time this is getting reduced, if we are testing with some row like 1, 2, 3, 4, 5, 10, or maybe 100 rows, uh, timing will be almost same. Either you are running for 1 row or 10 row, it is going to take with very minimal microseconds differences, and we will not be able to get that properly. If you really want to see, go with some good amount of data, then you will be okay to see, okay, for this 1 GB, this time this is taking 4 minutes and this time this is taking 3.5 minutes. Then at least a point 0.5 you are getting optimized times for processing time, right? So you can experience that. Anyone has any question, any input, anything? Always ask. Feel free to ask. Uh, Nothing is wrong, and none of the question is wrong. Our question can be silly because of our understanding that whatever I am asking, but actually that is a good question. All the questions are very good because from each of the question we are going to learn something, right? Okay, so this is created. Now I can do select the start from uh, table name employee test where id equal to 1. So if you see, I am not giving the index name, right? I am simply querying from table itself, but on top of this table, index has been built, so it will be faster. So like that, we can create the index. I hope that you people are good with this. Okay, just go with it once, and if you have any question, you can come back. Then I have already repeated this, but as I have mentioned here, I will repeat it again. Types of files in Hadoop. We have multiple types of files like you have text file, you have sequential, you have Auro, Parquet, ORC, RC, JSON, XMLs and all. Whenever you are doing the practice, try to practice with all file formats and you prepare yourself with the uh, like definition as well, like what is the difference between ORC and Parquet, in which condition I should go Parquet is useful, Auro is useful, ORC is useful, and how much compression it is having, which is better to use. So all these things you can keep in mind and try to do the exercise. In the beginning, you will not have all the file types as an input. So what you can do, you use your CSV data only and make your table stored as ORC, stored as Parquet, stored as RC. Then your output will be stored as ORC, Parquet, RC, whatever you have given, and take that data as input file next time. So initially you have CSV, You can create Parquet ORC file by storing that table as ORC Parquet format, and next time you can take the same output data as your input and you can go ahead with that. So you can follow that. Then additionally, you have map files, you have H files. H file is it is related to HBase, and then protocol buffers. This is kind of proto format for you can say compression. Okay, and then optimization techniques. This is the last thing in our Hive we are going to cover, and this is really uh, very critical thing where you should focus, because in interview if you are going, you can have some setup questions from Hive. If let's say someone is asking if you have experience in Hive and you are saying yes, then questions can be related to tables, type of tables, use case, in which condition you are going to use which kind of table. Optimizations, bucketing and partitioning will be part of optimizations only, which we already discussed. Views and indexing again part of optimization only. And when it is going to support you, what kind of support you are going to get from the bucketing, what kind of support you are going to get from partitioning, all the things you should explain. You should be good with this. Okay, so if someone is asking what kind of optimizations you are applying, of course, without optimization, as a developer, how you can think about that? Because as we are saying that we are going to deal good amount of data, and good amount of data is always concerned about timely delivery. On time delivery you have to do, and for on time delivery you have to keep your query running with optimization itself. Then only you can achieve your target. So here optimizations query are really very much required, that is going to improve the performance and dealing with the large data sets to make on time delivery. For that you have multiple options. Very basic optimization is partitioning and bucketing. You can keep that in point in interview. If someone is asking about that, you can simply say very basic thing, and first up optimization can be partitioning and bucketing, and then you can keep on adding the next part. So for partitioning help to divide the large tables into the smaller, more manageable pieces based upon the value of a specific column. Based upon that, you have made the partitions. Here is the syntax. Small syntax I have mentioned for your exercise. Then bucketing. Bucketing splits data into more manageable files on top of on top of partitions, or even without partitions also we can apply bucketing based upon the hash or a column for the user ID and customer ID. Then when to use. It is helpful for evenly distributed data set and for optimizing joins and aggregations. I had said yesterday that in partitioning, what is the drawback? Drawback is it is not considering for the evenly distribution. Let's say you are having the data from 2020 to 2024, 4 years data. Okay, 5 years data, not 4 years. In that case, you are going to do partition by year. Then in backend, you will be having 5 folders, right? There can be a condition that 2022 records 1 billion data, 1 billion records, 1 billion row, and 2024 is having some 10 billions records. 2023 is having some 2 billions records only. So if something is having 1 billion, someone is having a 10 billion and all. So counts are different, and even a good amount of differences are there. Good differences are there, but your partition will not take care of it, because your partitioning is considering only partition key. You are saying partition by year, then it will segregate the data based upon the year. It will not think about either data amount is same or not. And whenever you are processing, then which is having less amount of data, that will be very smooth to process. Which is having good amount of data, that may get blocker, because it is having really good amount of data. Let's say someone is having 1 GB data, and some partition got 10 GB data, then that is having 10 times more data, right? Of course that is going to take 10 times more time also, processing time also. So that is the drawback in partitioning, which you have to take care. You have to analyze the data, and you have to take care that how it will not be impacting the performance, how it will not getting blockers and all. because you do not have control over that. You have that will be your manual intervention. In bucketing, you can decide the number of buckets, and this will be always trying to have evenly distributed data set. That okay, you are saying that let's 4 bucket, then in 4 bucket it will try to, if not 100% exactly equal data, then at least it will try to match 95%. Okay, it will try to distribute the data in a even manner. And again, so that is one thing. And second thing is this bucketing helps a lot in joins and aggregations as well. Even joins, your partitioning is also going to help, but bucketing will be helping a, a step better. Then column format, columnar format. You are having lots of file formats. Above I have mentioned you have text file format, that is the by default in Hive for input also, output also. You have RC, ORC, Parquet, some other formats. Then you can choose columnar format, ORC and Parquet, that will be more optimized comparing to others. Even ORC is more optimized compared to Parquet also. Okay, ORC was mostly developed for Hive use case only, where it is having capability to compress the data up to 75%. So if you have 1 GB of data and you are using ORC, then your output will be your input. Let's say your input is CSV file, that is 1 GB, and you are stored as ORC. Then your input is 1 GB, but your output, which is stored in the HDFS location, that will be 0.25 GB. So you can think about how much optimization you are going to get. So you can mention this point also in the interview, that you can choose any columnar format that will be keep on performing better, and you can choose either ORC and Parquet, again based upon the requirement. If you straightforward, there is nothing requirement which is looking for Parquet, you can go for ORC. And if you need, let's say on top of Hive you are planning to read using a Spark, you are building a data pipeline with a Spark, and then you can plan about Parquet also instead of ORC. Even ORC also supports in Spark, not an issue, but based upon the business needs you can pick up. Then what is the benefit you will be getting? It is going to reduce the data storage size and speed up query execution by reading only the relevant column. Okay, how to use? Create table, table name, and stored as ORC. You can keep the file format which you want to select for the storing. Then this is ideal for analytical workload with frequent columnar queries, especially in read heavy environment. Then next is a predicate pushdown. Predicate pushdown is a technique pushes filters down to storage layer like ORC, Parquet before executing the query. You can apply that. Okay. Then you have map join. Map join we discussed. You can enable the map join whenever you have multiple tables to join, and you got that one table is a small table which can be fitable to memory. Then you can plan about avoiding all the data shuffling and all, and let's go with the map join, enable the map join. That will be making your query faster, because this smaller table will be loaded into the memory and it will be avoiding the shuffling and reducing stage. Then you have cost based optimization. In this option, cost-based optimizer chooses the most efficient execution plan, where optimized query plans for better performance, and you can enable this by this setting. Set Hive CBO enable equal to true and analyze table cells compute statics. So you can enable CBO and collect the statistics on the table. Then vectorization. For vectorization, this is a row tabular kind of data, right? You are going to store the data into the tabular format where you have columns and you have rows. That means it is going to do all the things row by row. Vectorization allow Hive to process batches of row at once instead of row by row. Any processing, if that is happening one row, then of course that will be slow. And if you are taking bunch of row, then that will be faster. So you can enable vectorization and then it will be going with bunch of row. By default, it will be going with 1024 records. Okay. You have to enable vectorization. This is the CLI command level. Set Hive vectorized execution dot enable equal to true. Then you have page execution engine. You have multiple execution engine in Hive. Okay. By default, it is having MapReduce. You can go with the page. So initially, this is Cloudera we have set up, right? Cloudera was a different company. Hortonwork was different company. Both were providing the distributed system to set up your cluster and go with the distributed model. Later they got merged. So when Cloudera was there, it was having by default MapReduce. Hortonwork was having by default Tej execution engine. Tej, you can understand this is the Indian name, Hindi, right? So this is the so owner also. If name is Hindi, then you can understand who is the owner of this stage. This is from India, okay. So Hortonwork had a Tej execution engine, and now both company got merged. So they have the option. Uh, Everything will be combined now, right? Nothing is default kind of thing. So now you can choose the execution engine, but Tej is having better performance than MapReduce, and even you can enable Spark execution also in your table. Here I can show you this one. Let me take here set Hive a dot execution dot engine, and it is saying by default I did not set anything. I simply am trying to set. It is saying Hive execution engine equal to MR means MapReduce. So by default as of now this is running with MapReduce. Then I can say equal to page. Okay, then I will run the same. Now it is saying Tej. So if I do Tej, then if I am running now any query, then that will be running based upon the Tej execution engine, not with the MapReduce. So we can change this also for the optimization. By default, again you can remember by default in Cloudera this is MapReduce. In Hortonwork by default it was Tej, but now both company has been merged. They are single company. So that's why this name is called now CDH. H for Hortonwork. Okay, then you have compression. Compressing data reduces storage space. If you have 1 GB of data, if you are enabling the compression, then of course it will be taking less space because data has been compressed. And this is speed up for data transfer also in the distributed environment when we are trying to read and write, means input and output. So this improves input and output performance, and especially for large data sets. Of course, if you have any time, if you have MB and KB of data, I don't think that even we need compression. And if you are doing compression also, how much you are going to get a differences? Some milliseconds, right? But if you are having good amount of data, then it will be impacting you for even hours also. Maybe you can have some time differences with hours, 1 hour, 2 hours, something. And if you are getting even more than a minute, then that is a lot. That is a good optimization. For this, you can set up any of the compression. Let's say you are taking Parquet file. Anyone has worked with Parquet file? Just a question. As of now, what about you, Alpha?
No, Anamika, only for that project which we were doing last time for, I guess, Hadoop or Hive, there is one exercise, right? I have not worked with Park anytime.
Okay, no issue. So whenever we are working with Parquet, then by default it has enablement with snappy compression. Okay, means that is designed in a way that by default, if you create the Parquet file, let's okay later next we are going with this Spark, right? We will be creating the Parquet file in our output, and then we can see whenever you are creating the Parquet by default, it will be having the snappy without doing anything. But for another file formats, we can enable. And Snappy is just compression. We have another compression as well. So whichever compression you are looking for that compression we can enable. So here is the option set high big compress output equal to true, output file input formats compress equal to true. So you have in Hadoop, we have multiple things. We have input, we have intermediate input, we have intermediate output, we have final output. Intermediate input and output is the mapper input, mapper output. Okay. means a mapper is creating the temporary output, and that output is a input for the reduce surface, right? So in that case, you can set up this, and then when to use. So for using this, you can take up that. Okay. And then if this is effective for both the storage and intermediate data compression. We can do the compression even file level, block level, and input file format, output file format. You can do that, and that will be making processing very much faster. Then we have parallel execution. We can enable the parallel execution by setting set Hive exec parallel equal to true. So how much set operations you are looking up whenever in the real time, whenever you are creating a script, Hive script, then all the points you can keep on the top. That will be helping you. Then reducing the number of reducer. By default, it will be having some number of reducer. If you look at this query, we run this query. Then by default, this is having one mapper, one reducer. Sometimes you will be seeing that by default, three reducer is coming based upon the data, based upon the logic. This will be launching some number of reducers. Number of reducers means that much shuffling will be happening. Not shuffling is not the number of reducer. Means based upon the number of reducers that there will be some impact over your shuffling and data movement. You can reduce that. So if you want to reduce the number of reducers, you can do set map reduce job map reduce dot job dot reduce equal to 5. So this will be giving some default number. Then skew data handling. Skew data handling, as we discussed about the partitioning, where you can have a condition that data is not evenly distributed between the partitions. Then it will be having the impact which is having less amount of data. Of course, that resources will be very much faster to process the data. Quickly they will complete their processing and they are done. And who is having good amount of data, that may get stuck, that may get blocker. In that case, you can think about that how you can overcome from there. And this is again one interview. In interview also, this you can face this question. Okay, what kind of issue you have faced, or what kind of challenges you have. You can make this point also in your challenge, one of your challenge. Okay. So skew data handling, where you have to so Hive allow optimizations for tables where data is skew. So certain key have a disappropriately distribution with the large number of records, and that you have to take care. So prevent reducers from being overloaded by distributing skew key separately. For that, you can do like here alter table. Then you can create one skew table. Aid is queued by country on USA, India, whatever country name you have. And for that, you want to have even distribution and set Hive optimize skew joins equal to true. So you have to set up this option, set this CLI command, and then you have, sorry, and you have to create, this is the CLI command you have to set up, and then this alter table you can do, and it will be taking care for the event distribution. Then file format selection. You can think about which file format you are going to select that can be more optimized, either RC, ORC, Parquet, Auro, which is good for the better storage, compression, and retrieval of data. And you can make sure that if I am saying ORC is good, ORC is not always good. ORC can be good for some use case. Parquet can be good for some use case. So you can't decide blindly that this is the file format. You know that this is good, but always scan your project, do proper analysis, understand which is the better solution, what can be more better, and according to your project only you take any decision. Maybe for your project verse is better, maybe for my project Parquet is better. So that can be the condition. So select a file format wisely based upon the requirement, and for that here you can set up the uh, format. Here set Hive input format equal to this ORC input format you are going to give. Then reduce the number of mappers and reducers. Above I had mentioned for reducing the number of reducer. Here I have mentioned for both. So for mappers and reducers, by default, based upon the data, based upon the query, based upon the logic, this will be taking mappers and reducer numbers. But if you want to have a control, you can set up that exec map reducer bytes per reducer true, number of map files, then sorry, merge map files, merge map read file. So you can do that, and then limit small files. As we have discussed in the previous sessions, a small file is a big issue where it can create lots of, suppose if you are creating lots of small files, that means that many replication, that many blocks, that many maintaining the metadata in the name node. So that can a issue, that can be a issue. In that case, you can think about that. So while processing itself, you can set up these things. Okay, set high, merge small files, average size. What is the average size you are looking for? You can mention that in bytes. Okay, then this will be the average file size. Then map reduce file. You can do this. Then limiting the number of rows to be returned. If you want to limit the row, then this is a simple select start from nothing else. So these are some optimizations you can apply in the Hive, and you can make sure that your query processing is faster. I feel that it was fine for everyone. If anyone is having any question, just let me know. All good?
Yeah, fine for me.
Okay. Okay, so these things you can keep in mind, and that will be helping you for all the processing, making that up to speed, and delivering the data, your output project means project deliverable over the time. That is going to help. So this is all about Hive, where you can go through all these things. You can go through exercises. Exercise I have mentioned in the same document. Also, you have exercise for each of the step. And if you go to this drive, you can see one of the use case for e-commerce sales analysis. Use case is provided. Even code hint is also provided. One use case is for Hive partitioning and bucketing. You can go with this as well. This one I yesterday I uploaded for that header issue. Okay, and this is one of the project. Again, I am not going to explain this today because this needs some additional things, so I will go with this later. So try, do not take this as of now. Even you can go through that. If you can think that you can do, then let's go. Otherwise, I am parking it for the later. And then, so just go with the exercises one by one. Don't take in a bulk. Otherwise, you will not be able to complete. Take one only, a small piece of exercise. Plan to do in 1 day, 2 day, 3 day like that, and then try to do. So this will be giving you more confidence, including hands-on. So you will not be forgetting. Otherwise, what happens once the course is over and we are going to discuss about some other module, then you will keep on forgetting from the previous one. Okay. Once you will do the exercise, then you will, if you are forgetting also, of course, 50 to 60% will be remain in your mind. You will not forget it. Next time, once one time you will revise, then everything will be completely refreshed and you will be good with it. So this is good to have the exercises and all. Hope this is helpful. Okay, then we are already with 8:47. I am not going to start next module. Tomorrow we will start. Uh, Niharika, you have the setups with the Hadoop. She's on mute. Okay, I will check her with her offline. Everyone is okay, right?
Yes.
Okay. Then if you have any question, we can go ahead. Otherwise, we can wrap up the session for today. Let's meet tomorrow. Okay, then I guess all good. Then let's meet tomorrow. Have a good day. Bye.
Bye.